Right, hi. I'm going to go through some of these harder Hegarty questions. I'm going to try to do them quite quickly so that the video is not too long. If you want to sort of fast forward, these are the questions I'm going to go through. So I'm going to go through that one, that one, that one, that one, that one, and that one. Right, first of all, find the perimeter of this, this green shape, given its curves are made from parts of circles. Right, so there's a few things you want to notice right off the bat. Is you've got some radius here, which is actually going to be 6.5 centimeters. So that's the first thing. So it's 6.5 centimeters, and this is quarter of a circumference. It's quarter because these are all 90 degrees. So one part is a quarter of the circumference, which is a quarter of pi d. So actually we're going to be using 13 centimeters in any case. So it's a quarter of pi times 13. So this is just this part here. It's just that part there. That's what we're working out. And I guess that's 13 over 4 pi. But then how many of these red parts do we have? We've got 1, 2, 3, 4 of them. So as soon as I have 4 quarters of this instead of just 1 quarter, it's just going to be 13 pi. So 13 pi is my final answer. If you want me to go through any of these in any more detail, you need to send me an email or ask me on Teams, because I cannot go into loads of detail on loads of questions. I cannot make, number one, I can't make hour-long videos. It's gonna take up too much of my time, like literally. Also, people don't really want to watch an hour-long video for a 50-minute lesson. So if you need any more help, you get in touch with me on either Teams or on email. Right, this one. Perimeter, so we've got half a circumference up here. So half of a circumference is a half of pi times 32. Right, so I'm using this formula here, c equals pi d, right? And the diameter for that part is 32. So I guess that's 16 pi, right? 32 pi halved is 16 pi. Then this part, if I do it with different colors as well, you know I like to use different colors. This part here is, again, that's half a circumference, but it's half of a circumference for a different size circle. It's a half of pi times 6, which is 3 pi. So that's that part. Then we've got this part here, which is again half of a circumference. So half of, so what is the diameter here for this bit of circle, this part? Well, 6 and 14 makes 20, and altogether it's supposed to be 32. So this part here must be 16, right? So this is a half of 16 pi, which is 8 pi. And then this last part is, well, relatively straightforward, right? It is just literally 14. Like, there you go, done. So my final answer is, how many pi's altogether? There's 16, add 3 is 19, add 8 is 27. So my final answer is 27 pi plus the additional 14. Right, next question. This is an area question. So this time I'm going to be using area is pi r squared. Let me just write that a bit neater. Area is pi r squared, right? So this is actually, like, if I color this in, let's use the highlighter. This top part and this bottom part makes one circle with radius 5. Again, if I'm going in too fast or not enough detail, you get in touch with me. You tell me, oh sir, you know, at this part of the video, I lost track. I didn't understand what you were saying. You can let me know that in an email. So the yellow part altogether is one circle, because it's like a circle that's been pulled in half. It's like a semicircle on the top and a semicircle on the bottom. So altogether it's going to have the same area as a circle with radius. Half of 10 is 5. Right, and then this circle, well, these two semicircles together on either side are going to have combined area of one circle with radius 1, right? Because half of 2, right? These are like the diameters. And then you've got the rectangle in the middle, right? So the rectangle in the middle, that's supposed to be the easy part, right? So what's that? That's a rectangle with just area 20. 10 times 2, 20. Obviously, it's going to all be in centimeters squared at the end. So let's answer this then. So this is going to have pi times 1 squared. This is pi times 5 squared. This is just 20. So this is 1 pi, which is just pi. This is 25 pi. So what have we got all together? Well, we're going to have 26 pi altogether. 25 pi plus pi is 26 pi plus 20. Right, next question. Find the area of the shaded region. Right. I'm not the best at questions like this, in the sense of I don't always know the fastest or most efficient way of getting the answer. So what I'm going to do is I'm just going to do it like how I would naturally answer it. I'm going to kind of, if you ignore this part here, so if you ignore this and just focus on this, which is called a segment. So if we just find the area of one of these segments and then double it at the end, we'll get the answer. So that's the mentality that I've got here. So I'm going to find the area of this one segment and then double it at the end. So the segment plus this triangle gives this sector. So let me just highlight the sector that I'm on about here. So this here is a sector. And here's the idea, right? We can actually work out the area of that triangle, and we can work out the area of the sector without too much problem. So whatever this is, we're going to add it to 12 times 12 halved, because it's half base times height. So half base times height. So I'll do that in a second. I'm just going to write down the formulas. And then this sector is a quarter of the full circle. It's a quarter of pi r squared. That's what it is. So I'm just going to do the substitution. So the segment is actually what we're looking for. Remember, we're going to double that at the end. Plus a half times 12 times 12. And this is supposed to equal so this sometimes happens when I use the ink tool and I'm recording. It like goes crazy. Never mind, right. So this is a quarter times pi times, what's the radius? It's 12, right? So 12 squared. So this thing that we're supposed to double, plus 12 times 12 is 144, halved is 72, And this thing here is 12 squared is 144, quartered is 36, this is 36 pi. So the segment is 36 pi minus 72, right? So the segment is 36 pi the segment is 36 pi minus 72, and so therefore this shape has area, so the actual shape we want has area 72 pi minus 144. So yeah, what you need to do is you need to think of it as being two segments, and then you need to work out the area of one segment. And the method for that is to work out the area of the sector and take away the area of the triangle that you're kind of removing from the sector to leave you with the segment. Okay, this question, right, so this type of shape here is called an annulus. And there will actually be a question on this in your BAM test when eventually you come back. Who knows how long that's going to be. So this type of shape is called an annulus. And the area of it is basically, it's a big circle. Take away a little circle. So the big circle has area pi times 5 squared. And the little circle has area pi times 2 squared, and therefore that's 25 pi, take away 4 pi, which is 21 pi. And make sure if it asks you to round to one decimal place that you're actually doing that. So 21 pi is 66.0. Be very careful, because Hegarty maths is very, very particular about making sure you've rounded correctly. Okay, so 66.0 meters squared, right, because it was an area. Right, last question. Right, so this is a circle minus a rectangle. The circle we'll deal with in a second. The rectangle is just going to be 60, right, 12 by 5. And then what the idea is how do we find out the area of the circle? So we need to know what pi r squared is. And therefore we need to know what the radius is. Now it's going to be actually not as hard as you might think to work out what the radius is, because we can use Pythagoras. Okay, so we've got a right angled triangle here. 5 squared plus 12 squared is 169. So this is the square root of 169. So I'm going to write 5 squared plus 12 squared is actually the diameter squared for us. This is 169 is the diameter squared. So 13 is the diameter, and therefore 6.5 is the radius. So this is 13. So we've actually got pi times 6.5 squared minus 60, which if I do 6.5 squared, it's 169 over 4 pi minus 60. Right, I hope that's helped. I'd like you to do some more work on this today, and we will be moving on to doing sector areas and arc length hopefully tomorrow. That's certainly what the aim is. Right, again, I'll say one more time, any questions you have to email me or ask on Teams. Right, thank you, bye.